wound onto reels. Essentially, the zip is finished, except for the handles and slides. For these, tons of aluminium are melted at over 400 degrees centigrade, then pressed through an injection mold to make the casts. Too hot to handle, these zip slides are then dragged into another room. Here, a rolling bin separates them from the frame. Making a zip is amazing enough, but the things they can do with a zip are even more amazing. How to zip up a giant bridge? Next, on How Do They Do It? For such an apparently simple thing, it's amazing how complicated it is to make a zip. The humble zip is an ingenious, intricate combination of plastic, metal and cotton, and it's got to be as hard-wearing as the clothes it allows us to slip on and off. Zips go through the same rigorous washing regimes as our clothes. If the dyes bleed or the fabric shrinks, it's a zip disaster. A sealed vat full of the coloured dyes rises to a temperature and pressure high enough to prevent the dyes from running. And to stop the fabric wrinkling up after washing comes ironing. Huge steam-heated rollers are used to straighten out any remaining little creases. Steam rather than electricity is used on the nylon zips because electric irons melt the nylon. As the steam irons keep turning thousands of miles of zip at the YQQ factory in China, another manufacturer, this time in Japan, is taking the zip into the 21st century. If you check the zip on your trousers, it's highly likely to carry a YKK logo. YKK is Lord of the Flies, and it's always looking for new uses for its zips. Everything from aquariums to spacesuits. They've even developed a zip house. Forget bricks and mortar, this all-weather shelter can be any shape you like and any size, and it's the easiest thing in the world to erect, because everywhere you look, there's a zip. It's strong enough to walk on, light and roomy, and it comes in all shapes and sizes, thanks to the zip. But instant housing is just the start. There's a myriad of other amazing zip applications. In fact, you may have driven over one recently because zips can also be used in large-scale construction. This is the Akashi Kaikyo Bridge in Japan. It's the longest and tallest suspension bridge in the world, and like a pair of giant trousers, it relies on zips. Right underneath the road, these engineers are doing routine maintenance. And how do they do it? Watch out for the zips. This rubber tube runs the full width of the bridge and is the ingenious solution to a problem that all metal and concrete structures suffer from. The road on the Akashi Kaikyo Bridge actually expands by up to 2 meters a day, which is enough to make it crack and break under the strain. Every day leaves its mark on the metalwork. This is why a bridge has expansion joints built into the road surface. These allow it to move by the 2 meters necessary for it not to break. However, along with this solution comes a problem. Asphalt and debris carried by cars and lorries fall through the joints, 30 meters below, onto fishermen and passing boats. The tiniest piece of grit from this height could be fatal. The rubber tube collects all this debris. The zip is the only durable and tough method of sealing it. There are zips all over this bridge. They're especially needed in places where the bridge is designed to move with the elements. For the next zip, the engineers have to climb over 300 meters to the very top of the bridge towers. You need a head for heights to do this job.
The zipper makes it easier for us to do checkups when we need to. The zipper also protects all the important parts of the bridge. Up here I get to look at the beautiful view. The big ships look so small passing under me.
Up here we find the next zip. The suspension cable has to bend over the top of the tower, where it moves backwards and forwards with the movements of the bridge. The zip is on a sealed protective covering to prevent any rust from forming which might stop the cable's natural movement. When you consider just one 3-meter stretch of suspension cable costs around $1 million, it needs a lot of looking after. Again, it's the zip that does the job. But the zips go on. Here's another critical place where a lot of movement happens, this time caused by the wind. The Akashi Kaikyo Bridge is built along a natural wind corridor that can blow up to 300 kilometers an hour. A scaled-down wind test shows how it can tolerate a movement of 8 meters from side to side. Unzipping the protective layer reveals the place where 2 sections of the bridge meet. This is called a wind shoe. The movement caused by the wind leaves marks in the metal over 1 meter wide, where the plates have ground against each other. The zip is the only thing that can protect the wind shoe from rust and still be flexible. You find the same deceptively simple marvel of engineering on the world's longest suspension bridge as on a pair of jeans. And to make a zip, it takes 1 day, 20 machines, and 200 workers. Behind the ordinary objects we take for granted lie extraordinary stories. Coming up, the secrets concealed in a soft drink can. Next, on How Do They Do It? It's August in southern Spain. It's hot, it's sticky, and it's time to strip off and head for the beach. It's now midday and the temperature has reached 50 degrees centigrade. The bathers are sweating like French cheese, and this beach bum has got one thing on his mind. He's desperate to get his hands on his girlfriend's ice-cold fizzy drink. Away from the sweltering beach, can maker Crown Holdings is defying the heat and running at full capacity. The operation is huge. But what strikes you most about can production is the speed. Every year, the world consumes enough cans of drink to circle the globe more than 500 times. And that means deploying an awesome array of high-speed technology.
We're producing these cans with the same kinds of technology that are being used in the aerospace industry, but instead of producing one satellite a year, we're producing over 2,000 cans each minute.
So, how do they do it? The can starts life on a roll, a large reel of tin-plated steel. In the canning trade, they call it a coil, and from it are stamped thousands of these, flat discs, known as cups. A monster die press stamps them out. Cut from the steel roll, the newly formed cups are launched on a high-velocity, 3-kilometre trajectory arcing through the plant. It's going to be an incredible journey. First stop, these giant machines. They're called body makers. Their job is to ram the cups into a cylindrical shape. After some trimming work, the cup moves on. Next, it's the war on rust. Cold, fizzy, soft drinks just love to corrode metal. The people at Crown have found a way around that. They spray the inside of each and every can with an epoxy coating.